Welcome to lesson 4.2, where we're going to talk about L'Hopital's rule. Now, we're going to do a little bit of a flashback to when we did limits. So do you guys remember back when we do a limit like this, and we'd have something like that. And we'd plug the limit in, direct substitution. And we'd get 0 over 4 minus 8 plus 4, 0 over 0. And we talked about back when we did limits that if you got 0 over 0, that meant there was a hole and you would have to do some simplifying. So we'd factor this bottom one to x minus 2 times x minus 2. Cancel those out. And then we could go from there. And this is still an asymptote, so it wasn't a perfect example. But we did a lot of limits like that where you'd get 0 over 0, simplify it, and then plug it in. Well, L'Hopital's rule is a shortcut for that. Basically, this is what L'Hopital's rule says. And keep in mind, there are conditions. So just like we've talked about in the past, if you have a theorem that has conditions, you must prove the conditions are met before you use it. So here are your conditions. Let's see. There we go. Right there. The if part of the statement. If the limit as x goes to c of the top and the limit as x goes to c of the bottom are both 0, or if they are both plus or minus infinity, then the limit of the originals equals the limit of the derivatives. So we can take the derivative instead of simplifying and doing all that algebra. You can take the derivative instead and you should arrive at the same answer. So let's practice it on this first one. Now remember, we always need to show our conditions first. So our conditions for this one, we need to show that the top and the bottom both go to 0 or both go to infinities. So the limit as x goes to infinity of x, that's infinity. And the limit as x goes to infinity of e to the x, that's e to the infinity, or infinity. So this is an infinity over infinity, which means we can apply L'Hopital's rule. In my calculus class in high school, we always called it L'Hospitals. Anyway, so we can now apply this because we know that the conditions have been met. So now I can say the limit as x goes to infinity of x over e to the x is going to equal the limit as x goes to infinity of the derivative of both of these. So the derivative of x is 1. The derivative of e to the x is e to the x. And now, if I have the limit as x goes to infinity of 1 over e to the x, that's going to be 1 over infinity, which is actually going to, let's use some arrows, 0. Because our denominator is getting so big, it's going to 0. Okay, let's try the same thing here. Conditions first. So we have the limit of the top. That's going to go to infinity. And the limit of the bottom. That's going to go to infinity. So this is an infinity over infinity. So L'Hopital's works again. So now I can say the original limit is going to equal the limit of the derivatives. So derivative of e to the x is e to the x. Derivative of x is 1. So I get the limit as x goes to infinity of e to the x, which is infinity. Make sure I'm doing this right. Yep, actually, Gary said we can do equals, so we'll do equals. Okay, let's try number 3. Always do our conditions first. So limit as x goes to 0 of x is just 0 from direct substitution. And as x goes to 0 of e to the x, so that's going to be e to the 0, which is 1. Now notice, this is 0 over 1. That is not one of our L'Hopital's rules form. So L'Hopital's rule, L'Hopital's does not apply. This is why we always check those conditions. Okay, I want you to try number 4. So write out the conditions first to make sure that your conditions are met. You get 0 over 0 or infinity over infinity. And if the conditions are met, then take the derivative of the top and the derivative of the bottom and see if you can then do your limit. So pause the video, try out number 4. Okay, you should have gotten -9, but let's walk through this in case you didn't. Limit as x goes to 0 of 3 minus 3 e to the 3x. Plug in 0, so I get 3 times 0 is 0. E to the 0 is 1. 3 times 1 is 3. And 3 minus 3 is my 0. And then limit as x goes to 0 of x is 0. So here I've got my indeterminate form, 0 over 0. So I've got down here, I can apply L'Hopital's rule. Set it equal. Take the derivative. The derivative of 3 is 0. And this derivative I have to do chain rule. So the derivative of e to the 3x is e to the 3x times derivative of the inside, so times 3. Derivative of x is 1. So simplify this, I got -9 e to the 3x, which now let's plug in my 0, so -9 e to the 3 times 0, which is -9. There we go. Okay, let's do, and we're going to skip number 5 for just a minute. Try to do number 6. So pause the video, try out number 6 with your conditions and everything, and then let's come back and see how we did. Welcome back. You should have gotten -4. So once again, check that our conditions are met. Plug -1 into the top, and we got 0. Plug -1 into the bottom, also get 0. So that's a 0 over 0, so we're good to use L'Hopital's rule. And so I use L'Hopital's rule, take the derivative of the top, derivative of the bottom, and then plug it in to get my -4. Now, you might say, Mrs. Johnson, this is a lot of writing. I'm sick of it. I'm sorry. If you don't write it just like I have here, you will lose points on the AP test. So make sure you're writing out your conditions and that you're applying L'Hopital's rule. If you don't state which rule you're applying, you could also lose points. Okay, last problem for this video, number 5. We're going to do this problem without L'Hopital's rule. You'll notice it is the same exact thing as number 6. So we're going to use our old strategies to show you that L'Hopital's works as a shortcut. So what I'm going to do is simplify this out. So x squared minus 1 is x minus 1, x plus 1. Cancel things out just like we did last chapter. So I have 2 of x minus 1, and then plug it in, which is 2 times -2, which is -4. So then you can see whether you use L'Hopital's rule or do it the old way, you get the same answer. So that's it for this first video. In the next video, we'll talk about how you can do L'Hopital's rule multiple times on the same problem.